name is Zachary Malus, and this is my experiment, the study of helium diffusion in different types of helium balloons. I'd like to thank the judges, my teacher, Carrie McQuarrie, and the fair organizers for allowing me to present this project today. The main question was if helium diffusion would differ when using various types of balloons and with the application of hairspray to the surface of a balloon. My hypothesis was that if different types of balloons are used and/or if hairspray is applied to the surface of the balloons, then the rate of helium diffusion will differ. So here's my material list. I used 4 different types of balloons, and one of them was split into 2 categories, hairsprayed and non-hairsprayed. In short, my procedural plan involved filling each balloon with helium and recording its weight over time using a precise balance. This is a sample of just one individual run, and this is one of many runs performed during the experiment. You can see key terms at the top. This is a summary of the entire experiment. These rows represent different balloon runs, and each column represents a piece of data gathered from its respective run. Some of the columns aren't applicable, as some of the columns are only for linear decays and some of them are only for exponential. For example, it's completely impossible to calculate the decay rate percentage for a linear slope. So using the data gathered from the individual runs in the final summary table, these graphs were generated. You can see on each graph that there's an equation, and the equation is the equation of the line displayed. So one particularly interesting thing about the Mylar balloons is that they all started very similarly, with a quick drop followed by a plateau which lasted for around 1 to 2 days. This plateau was then followed by an almost perfect linear decay. Because of this, the strange beginning was, well, not entirely excluded from the line fit. This is the summary graph. It is the result of taking the average line equation for each balloon type and graphing them all with a y-intercept of 10. The dotted line of each color represents the weight of each respective balloon. When the dotted line of a color and the grams of lift curve of the same color meet, it indicates the failure point of the balloon. It fails at this point because the upwards force of the helium inside the balloon becomes equal to, and then less than, the downwards force exerted on the balloon by gravity. So in conclusion, the hypothesis that if different types of balloons are used and/or if hairspray was applied to the surface of the balloons, then the rate of helium diffusion will differ was accepted. A very interesting thing that I noticed is that some of the balloons caused a linear decay and some an exponential decay. A reasonable explanation as to why the different types of balloons have different decay patterns is that the diffusion rate depends on the thickness of the barrier over time. When latex balloons, which have an exponential decay, are inflated, they stretch. When mylar balloons, which have a linear decay, are inflated, they do not stretch.